So, Sonic Pi, how it works currently. We have a GUI, which is in C++, which then starts up a Ruby server, which is a separate process, which then starts up SuperClider, and it also starts up the Beam, which is the virtual machine for Erlang. SuperClider is for the sounds, and Erlang is for the MIDI currently and OSC stuff. And yeah, they're the main sort of long-lasting processes. Yeah, IEEE have it so that you can only comment if you followed for more than a few weeks. Crikey. Yeah, I've just put it for 10 minutes. So that should be enough, hopefully. A few weeks is quite an incredible barrier to entry for being able to chat. But yeah, let's see what happens. Okay, so the thing is, what I'm trying to do today is start refactoring how these processes are spawned up and also how they're monitored. Because currently, we've got a slightly ad hoc system, well, pretty much everything in Sonic Pi is ad hoc. The GUI starts with the Ruby server starts up the Beam and SuperClider. This is because mainly this Ruby server seemed to be like the core primary part of Sonic Pi. But actually now we're moving towards having the Beam be the core primary part of Sonic Pi. And moving more of the functionality over there. But still, regardless of that, having multiple things start up other things is a bit ad hoc, and means we currently have a bunch of code in C++ doing spawning of processes. We also have code in Ruby doing spawning of processes. So probably unifying them to one place makes sense. But also more problematic, really, of the current design is if the GUI crashes, say, and that happens, right? You make bad code, then these processes may still be running in the background, and they are turned into zombie processes, and those zombie processes are annoying, really. They're in the background, maybe they're taking up your resources and you don't realise they're running in the background, and that's annoying. So what Sonic Pi currently tries to do is, when it starts, it looks for all the PIDs, the process IDs of these things, and logs them in a local file, and then when it starts, it looks to see if any of those PIDs are still running from maybe a previous iteration of the program, and then make sure that they're the ones that were spawned by Sonic Pi, and then attempts to kill them just to try and clean up after itself. But that it feels messy, doesn't feel quite right. So I want to experiment with a new design, and this is to basically, obviously, when you want to make things simpler, you make them more complex. That's the plan. So my plan currently is to have the GUI just spawn up a daemon, which is a very simple process, and the daemon process is going to be hopefully simple enough and to code to make sure that the number of bugs, the number of issues it can have is minimized, because it's not going to do much. The only thing it's going to do is it's going to spawn all the processes. And once it's spawned the processes, this process is here, it's going to remember their PIDs. So this is like PID 2493, 476, whatever, 3, they're probably actually quite similar numbers, whatever, in memory. So it doesn't have to store anything in the file system, it doesn't have to remember it over iterations. And then it's going to monitor these things. In particular, it's going to monitor the GUI, because the GUI is really the main entry point. And if the GUI crashes, it needs to be able to know that's happened, and then it can go off and kill any of these processes that are still running. So you can go and kill this one, kill this one, kill this one, kill this one, kill itself, and everything's tidied up and cleaned. If that makes any sense. So that's the goal, is to try and implement something, the basics of this, of something that will enable me to monitor the liveliness, this connection of these two things. Does that make any sense? So the plan really is to do that monitoring by having a TCP IP connection. so a socket connection between these two things, and to have it sort of ping pong backwards and forwards, an alive message, and if that TCP IP connection is closed for any reason, then we know that the GUI has died. Or if the daemon sends a hello message and the GUI does not send an ACK back, then we also know that the GUI has died as well, if we wait for a timeout. So we're waiting for either the socket to be closed or a timeout. Then we know we know something's gone wrong, and we can nuke all of our processes and we can carry on. Why keep it as different processes and servers if all get destroyed and one dies anyway? They don't all get destroyed. Well, that's the whole point, right? The problem is right now is some of them get destroyed depending if they crash, but there's nothing really that's monitoring and observing and making sure they all die. All we have at the moment is that when everything starts, we log all their PIDs, and if things close correctly, then we go through all those PIDs and we kill them. But if things don't close correctly, then they can be left in an erroneous state. But next time we start, we looked for the last session, for the last PIDs, to see if they're still running, and then we go through and nuke those. So it kind of like it requires the second iteration of the program to be run for those old ones to be killed if there was any zombie processes created. So I want to avoid that. As Baggins is asking, how I was able to link dev coming on. Well, this work here actually is part of that. This is the link stuff required the processes, the order of the boot to be changed, and that caused all sorts of weird issues. And so rather than trying to fix ad hoc nature of how these processes are spawned, I thought it'd be really nice to actually spend the effort to unify the boot process, to do the monitoring, to improve all that stuff first, and then we can move on to link stuff. So it's getting there, but these things take time. So does this make sense? So I'm interested to see how I'm going to do this. So what I'm going to do is I'm going to experiment with the simplest thing I can build to get towards something which enables me to do this observation here and these TCP/IP connection here. So what I'm going to do is I'm going to figure out how, and I've already done a bit of research to figure out how I'm going to start with this. So hopefully that's going to help. But I've got a C++ and I've got a Ruby. I'm going to implement my initial daemon in Ruby, and I need to be able to do a TCP/IP connection between these two languages. So I'm going to build a program in C++. I'm going to build a program in Ruby, and I'm going to hopefully have them talk back to each other over a TCP/IP socket connection. And so it's really a question of which one of these to start with, but I'm hopefully going to be able to do both of these in this session. Let's see how it goes. Any preferences on whether I start on the C++ side or the Ruby side? Anyone got any thoughts? So if I let's have a look at let's find a browser. Let's make a new browser. Bring it over here. So if I do someone wants to start with Ruby, that's probably a good call. And someone wants to start with C++ because I have no idea about Ruby. That's a good question. I'm going to start with Ruby actually because I think that's the easiest. C++ is a bit of this network stuff does not seem to have any standard libraries for it, whereas Ruby does. So let's look at Ruby TCP Socket. There we are. So you can see actually there's an older version of Ruby here, but there's a TCP Socket thing. And look, I can just write this code. So it says here, I need to require the socket library. I need to create myself a TCP socket, and so in Ruby we've got this variable here that's going to be the socket. This is the class which is going to call the new, which is an initializer, and pass it these parameters. So we're going to have a socket which is connecting to the local host, the current machine, on port 2000, and then it's going to here's a little loop while we are able to pull out lines. So S is our socket here, and get string. We're going to try and read a line from it, and whilst we do that, we're going to print it to the screen. So it's just an echo server, and then when it gets no more, which I assume must be like a empty line or something, it's going to then close the socket. So that's pretty simple. So let's see if we can see if we can get something like that going. Let's make two Ruby processes. Let's start with Ruby to Ruby. Let's just go like this. So we're gonna create a server. We're gonna create a client, and then when we've got this working, then we can switch to C++. Can we see your screen? Yeah. Oh yeah. I'm showing you my code. So let's Duke. Here we are. This is what I'm showing you here. Sorry. I was reading this code out here. This is one of the examples from the just a Ruby documentation. So what we can do is just copy that, and over in let's find this terminal. Let's make a directory. Let's call it what should we call it? It's a good name. What's a good name for the naming is hard. Call it Overtone. I mean that's already exists. Let's call it netcoms. So let's go to netcoms, and let's make in here. Let's make a client RB and server RB files. And so they're just there, and then over here in Emacs I can just open up those files. So let's go to development temp netcoms, and let's do the client, and let's just paste in the code we saw from the example. But before we do that, let's just verify we actually can run some Ruby code first. So let's just comment it out and just do like print hello world. Let's just make sure we can do something. And in here, let's call. Now, do I have Ruby installed on this system that's visible here? No. But I do have it as part of Sonic Pi in the tree. So if I do this, Sonic Pi server native Ruby bin ruby.exe and call, which one was this server? Hello world. Brilliant. So I can run a Ruby script. That's a win. Thrumpunter says, I remember making a presentation about it at uni, about Overtone. Cool. That wasn't such an old school system. Nice though. People are still using it, which is brilliant. Overtone suffered though from being too complex, I think, and had such a high barrier to entry. You had to really understand sound synthesis techniques to make a sound, and also understand closure at the same time, which was just too much, I think, for most people. You can either do one or the other, and it's already hard work. Doing both at the same time was hard. So creds if you can do that. I'm officially a programmer. Yeah, I've made a script which prints "Hello World" to the console. Let's do that again. Look at that, brilliant. So let's just keep that in there. Let's write like a welcome to the TCP server, and then let's get this code going. And let's also, every time we go around this loop, let's just write, first of all, let's put some debug here. About to create a socket. Use puts, so I don't have to do carriage returns. And then here I'm going to say like socket created, and inside the while loop I'm going to say like getting data from client. Right, so let's try this. So it looks like it's waiting for a connection, and it says here, look, no connection could be made because it refused it. Refused. I wonder if that's because it's a too low port number. Let's try a different high port number. Or maybe it's waiting for a client to connect. So let's just keep that like that, and let's go to our client and go to our documentation and see what a TCP client looks like. simple socket, and what have we got before? Oh, hold on, I was using the socket before, and actually what I want is a server. That's no wonder it didn't work, because it was attempting to connect something that didn't exist. So I'm getting them swapped around. So let's put that there, and put this down here. So let's go back here again. So welcome to TCP server. Require, and is it, yeah, socket. So we create a server, and so let's make that. Create a server. Server created, and then what we're going to do, it's going to accept, and then it's going to print hello, and then put the time, and then close. So we've got these different phases. So the server accept is like waiting for a connection, and so a TCP server typically you can have multiple connections simultaneously from multiple clients, and here we're just waiting for the first one. We're then working with that first one, then we're closing. So this will only ever accept one client as it currently stands this code. Although it'll loop around and wait for another one. So let's not do the loop. Let's just have one client like this. So, and then let's put some more print statements. So waiting to accept connection. Established. Exclamation mark. Right, so then it's these messages here are not going to be printed to the screen, hopefully, but they're going to be what are we doing here? Print is printing. We don't want to print this one. We want the server. In this case, let's just have it switch it the other way around. Let's do this one, do the sending. So let's look at this. So we're getting a socket, we're printing out, we're getting it, we're making a server in port 2000s, putting some debug, we're accepting a connection, and we're creating a socket for that connection, and then we say we've got it, we're going to get some data, and so here we say client dot get string, I'm assuming, data equals, and then puts the data, and then close the client. And maybe do you do server.close? No. Let's guess that. And let's run that code. Look. So it's asking me, it's waiting, it's the firewall's been triggered, so it's obviously trying to receive information. That's probably because it's accepting it from any machine on my network. So let's not do that. Let's just accept it on localhost. It's on loopback network. Let's try that. Right. Okay. So yeah, this doesn't trigger the firewall because I'm not accepting messages from any machine on my network. So it's not like a security thing. Sometimes you want to be able to accept messages from any machine on your network. Sometimes you just want them to bind locally. And in this case, because I'm doing process communication between processes on my current machine, there's no need to open the port up to other machines. So therefore we don't get any kind of firewall issues. Okay, so it's now waiting for connection, and it's sitting there waiting nicely, which is brilliant. That's what I was kind of hoping. So let's leave that there, and let's do our clients. Development temp netcoms, and here's our client here. So in a client code, we're getting a socket, creating a socket, we're going to bind to the same IP address, which is the local loopback network, on port 2000, make sure the numbers are the same, and it's not going to do this, it's just going to print, it's going to send it hello. Just do one message, that's just for that. And then it's going to do Let's see if this does anything. And if it does, we'll explain what's happening. So I'm going to start my Ruby executable. So I've got a executable for Ruby embedded inside SonicPy. So I'm just now starting that, using that to do the execution of the Ruby stuff. Client.rb. Hey, look at that! Totally worked. So look, up here, we've got hello, time is, and then we've got some long computery nerdy time string. And then they're both completely finished. So that's great. So I was able, therefore, to have two separate processes talking to each other over TCP IP, over TCP socket. That's a win. Okay, so shall we go through this? Are there any questions about how this is working? So I'm not sure if I went through this too quickly or too slowly or mumbled over bits, and but let's have a look at this. So in Ruby, puts just means print a string to the output. So it's like in C++, you might have like, oh no, what's going on? Like this kind of thing. We'll see this in a moment. And Java, you might have like system.println. Don't forget your semicolons. This kind of stuff, right? These are just ways of printing stuff to the terminal. And so in Ruby, it's this. Then what we're doing here is we're pulling in a built-in standard library called Socket, which allows us, gives us access to these kind of objects. In Ruby, everything's an object pretty much. Not everything, but most things are an object. Classes are objects, and TCP server is a class. And it has a new initializer, which allows you to create new instances of that class, and you pass it some arguments. One of the nice things about Ruby is it sort of doesn't require you to put all these sort of parentheses in, semicolons, although you can, and that still is valid Ruby code. It's not necessary in all cases, so it's nice to omit those and keeps the code a bit cleaner. So what we're doing here is we're pulling in the socket library, and then we are initializing a new TCP server that is bound to. You have two concepts with it with the TCP IP. One is the IP address of, so that's the sort of the name of the computer that you want to listen on, and here we're doing it on our local machine, and that's 127.0.0.1 is the IP address of your local host, and we're also listening on a particular number. So this is the port number. So you can have multiple TCP servers running on the same computer, all listening on different port numbers. It's kind of like having an office with different telephones, each with their own number that you can connect to. And so here we're just connecting to port 2000. We're hoping there's no other process running on that port on our machine, and sometimes there might be. So this code, to make it a bit more robust later down the line, we'll have to do a bit of observation to see if this port's available, or maybe even actually you can omit that and it will create use an unused port for you. But then you have a problem then of like telling the other machine, the other process which port to use. So let's just stick with this at the moment. So we're just saying bind to port 2000, and then further down here we're doing the accept phase. So that's kind of like once you've created this server, it's there, it's ready to receive messages, but you have to then say I'm ready to accept new connection. And so once you go into the accept phase, you then wait for a client to connect, and when that one client is connected, then you then create a pipe between you and the server. So the server goes into the accept phase, and once this thing is sort of waiting and hanging around here now, and then when the client initializes a connection, it then moves out of the accept phase and is in the the working phase. There's probably a nice term for it. And then at that point you have this pipe, data pipe, which then allows you to send bidirectionally, so from the server back to the client, from the client back to the server, you can send data back and forth. Arbitrary data, whenever you want. And so this is, whenever you do an HTTP request, for example, this is exactly how it works. If you're doing WebSockets, this is exactly how it works. And you're just sending data back and forth. In fact, we can probably even try and connect. In fact, I think actually the C++ example, the library we're going to use, has a example where it does use, as its example, implements a HTTP GET request. So we can try that in a bit. But it's exactly the same kind of approach. Instead of sending hello, time is now, you just type in the right string, get / and then you say HTTP version 1.1, and then you'd say which hosts that you're getting from, because a IP address might be running multiple web servers, each with different domain names. So yeah, so then you specify which server to pull your HTML from. There we go. So yeah, so we're waiting for our connection. Oh, so I'm showing you the wrong thing now. We're waiting for our connection, and then after that, we're then waiting for data, get some information as text. And so when that data comes through, we print it to the screen, and then we close. And so that's what happens here. So let's run this code again. You can see here it's welcome to the TCP server. We're about to create a server, it created the server, and now it's waiting. So it's sitting there hanging, waiting. So this is, if you implemented like if you're implementing your own web server, this is kind of roughly what you would do, is you would have it wait for an incoming HTTP request, and it would be sitting there just waiting, and when anyone comes in, it will then feed back the HTTP response. And so over here we have an entirely different script, which is the other side, it's the client side. And this is going to connect to the same local host on port 2000 and then send it some information. So let's send it there. Hello there. How are you? Question mark. The time is whatever. Save that file and then run the code. And now we can see the top file. It's now come out of that waiting, accepting state. It's printed my message, and then everything's quit. So that's all good. Any questions at this point? So we've done this kind of thing. So what we'd want to do actually, let's just spend a couple more moments whilst this is working, is we want to have this connection going, and then we want to basically enter a loop. So once we've got our connections, so let's go to the server. And here, let's go for a loop here. And let's get the data, and then let's loop around. So we're actually never going to close. We're just going to keep looping forever. And so now, let's run this, and let's run this one again. And what's happened there? It's kind of like printed loads of. It's printing loads of nils. Interesting. Let's see what happens here if I put something in here. Now look at that, it's pretty high loads. So it seems to be getting data from the stream. I wonder why. It's still getting data. It seems to be lots of nils. It's interesting. Let's have a look at the documentation of the TCP server. The printing, client.gets, puts data, client.gets. I would have thought that wouldn't maybe. Let's inspect what the data is. It's a load of nils. Interesting. I would have thought it would block waiting for the next bit of data. So let's have a look at this. accept. Turn to socket. And a socket has So this is what's happening here, but it's actually just checking to make sure it's not nil. Interesting. So if I do the same kind of thing rather than just enter a loop, it'll just stop, I assume. Yeah, so it's got some data and then stopped. Now what happens if I do a loop here and just keep printing the time? Cool. Okay, so it must be the case that when the socket gets closed, in this case, when this close happens, this then gets nil all the time. But because we're not closing, I mean, if I don't sleep here, if I don't close, let's think about this. If I don't do the loop and sleep for 100 and then close, is it just going to pause and wait? Yeah, okay. And I should be able to now turn this back into a loop. Yeah. So I assume that what's happening here, at least with the implementation on Ruby side, that when you close the connection, it's just sending nils down the wire, and it's just getting nils. So that's one way of knowing if the socket is closed, is reading that nil value. Because we haven't closed it, because we're basically sleeping for 1,000 seconds, even though we're in this tight loop, it's not spinning around loads of times. That's interesting. Cool, but this is essentially what we want to have, is we want to have it so that we're detecting if the client has closed or not. So let's go back and here. This kind of code is nice. And let's print the data. Let's get rid of that. And here. So now we know that as long as we're in this while loop, we've got a connection, and that's great. And then when the connection is finished, this is the point where you can then kill all spawned long living processes. So back in this thing here, this is where you would kill these things here. You know you're in a phase now where the connection has died. Let's kill all these the processes you've spawned, and we can move on. So what we've got now is we've got a implementation of a client and a server here, and they're talking to each other, establishing connection, and then when one of them closes, the server is aware of that, and then it can enter a new phase. So this is nice. So what we can do is we can here, before we do this, we can do the spawning of all the processes. Then we can let's do it right at the top here. Then we can establish our connection, wait for it to finish, and when the connection's finished, either because the connection crashed or because the GUI closed down correctly, then we can then move to the next phase, which does to kill the processes, and then we can close down effectively. This is good. Right, any questions at this point? It's making sense. Seems to be making some progress. So the next thing is to implement this in at least this part in C++, because the GUI, this is going to be in part of the GUI, right? So the GUI currently is in C++, so we need to have the equivalent logic here implemented in C++. So if you have any more questions about the Ruby side, let me know now and I'll address them. Otherwise, I'll move to implementing this in C++. Waiting for questions. I don't think there are any. It's good. Okay. Now, C++. First thing we need to do in C++ these days, seems, is we need to make a file called cmake lists.txt. And this is our hello and welcome to C++. This is our file we're going to use to describe our project, and it will be the file that we use with our build tool cmake in order to compile all the things. And we'll get that to a second, but we also need another file. Let's kill these things. Kill this thing here. So in our netcoms, we're going to have a file called main.c++. And let's open that here. And in the main, in C++, typically we're going to have a function called main, and it's going to do something. So let's just do the print hello world equivalent. So standard cout hello world, and then standard endlet, and then we need to use, does it use? Does it require? I can never remember these things. IO stream, something like this. And then in our cmake file, we need to tell it which version of cmake to use and where the things are to build in the project name. So let's have a quick look at this. So cmake. Right. So this is the tool we're using to do building. It seems to be pretty much a prolifically used tool in the C++ world these days. And there's a lot, it does a whole ton of stuff. We're only using the very basic things. So let's look at the documentation. And look at the latest thing, and let's have a look at the introduction. And is there a getting started tutorial? Introduction. Here we are. So a basic starting point. Basic starting point is an executable built from source code files. For simple projects, a 3-line cmake text file is all that's required. So let's copy and paste this into our cmake lists file, and we can see here we give a project name, so let's call that netcoms, and the netcoms project has a file called main.c++, which is this file here, and that should be it. So we've told it which version of cmake to use, we've told it the name of the project, and we've told it where the main C++ file is to compile. So now in our oh, look at that, I've spelt cmake lists incorrectly, so let's fix that. I think you have to do it like this. Let's kill that file. Let's open it up again. Right. Okay, so now we can. Where you do this now is to create a build directory. So you can do it a variety of different ways, but a nice thing to do with cmake is to create a build directory, and then all the building stuff. Let's make from first. All the building stuff happens to go into that cmake, into that build directory. So if you delete the build directory, you get rid of all of the linking files and the object files, and all the kind of gubbins that cmake creates. And it does a whole ton of stuff, as you'll see. So we go to integer build, which is our empty directory. We need to then run cmake, and we need to tell it where the CMake lists file is, or the directory of the CMake list file, which is the directory above. And then it will then generate you a ton of stuff, all the makefile things, for your platform. And so if we have a look now, we can see we've got a whole load of files here, which is why this is good to put it into a separate directory, because it kind of clutters things. And these are all ephemeral in the sense they were built by the CMake tool, and you can rebuild them just as quickly as we built them there. These then we can use to open up in our IDE, or in this. So if you wanted to open up in VS Code, or I think if you run this on Linux, it'll generate you different kind of makefiles. Same for macOS as well. But the way I tend to build things, the only way I know how, is just to use CMake itself. So if I say cmake.exe and then say minus build current directory minus config, because you can build different kinds of things with different amounts of debugging information in. But let's just go for a release build here, and it's got some problem. Look, so the compiler now has told us that our file was incorrected. So line 1. So do we need to put a semicolon? Maybe I just guessed this stuff, right? So I think that probably is wrong. Yeah. C out, standard out, C out. So let's look at this. So C++, hello world. Let's look at that. Hello world. Is there a simple... Look at that, I've got the wrong thing. So it's include IOStream. Include, and then we don't have a comment. Let's try this. Woo! We have something which is compiled. Brilliant. And so now, once we've got this compiled, we can then run it. So we need to see that it actually has created a directory called release. If we look inside there, we have our netcoms.exe file. So netcoms.exe, and we can see that, yep, it's printed hello world. So we're winning. So we've now compiled a very basic C++ program. Now, I mean, there's a load more extra steps than we had to do with Ruby. With Ruby, we just created a script, and we passed the name of that script file to the Ruby executable. Here we're having to use CMake. I mean, you can do it on the command line to do compiling, but once you get to any kind of level of complexity with C++ projects, you definitely want to be using CMake. And we're doing a hello world executable, which obviously means this is way faster, although you can't really perceive the speed of the difference because they were just printing to standard out, both the Ruby and C++. Yeah, and we're working, so that's good. So the next thing is to figure out how to do some network communications. Now this is where I stumbled a bit, so if anyone's got any advice on how to do this better, I'm totally all ears. But it seems that, at least in the C++ world, there's no standard library for doing TCP stuff. So you have to basically drop into the operating system specific headers and libraries, and so there's like WinSock, I believe it is, on Windows, and then there's whatever it is, sockets or something on Linux, or POSIX on Unix, macOS. And so you end up having to write two different programs with similar APIs at the same time, which is pretty annoying. So then I was digging around, and I discovered something called KISSnet, I think it was called. Kiss. Let's find KISSnet. And somebody's gone to the effort of writing a cross-platform API which abstracts over the differences between the different operating systems. So this runs on Windows, Linux, FreeBSD, even like Haiku. And we've got some simple examples of how to get this to work. So let's see if we can get one of these examples to work. So here we're getting a socket. Notice it's quite similar to the Ruby code. I mean, there's a lot more stuff going on. You gotta do a lot more. You gotta be more explicit with things. But essentially, here's our new socket. Here's the IP address. It's going to a remote thing, but this could be our local host. This is port 80, so this could be obviously port 2000. We connect to it. we're creating our string to send, and then we're sending that string using all this other sort of, you can kind of ignore this stuff at the moment. And yeah, it's also doing receiving stuff, which we don't need to worry about right now. So let's copy this. Oh, that's me doing some performance in the background. Right, okay, so let's find our C++ file and copy this across. So here, I'm assuming we put our 127.0.0.1 and port 2000. You can see here actually that it's doing an HTTP GET request. I mean, let's try that actually. That's for fun. So let's go to sonic-pi.net port 80. So we're going to actually see if we can get some data from the web server, and the host we're going to is sonic-pi.net. So this is a very basic HTTP string, the raw data that's sent whenever you go to a website. You're saying, I'd like to get some information, please. That's the GET request. Here's the resource that you want to get. In this case, just slash, which at HTTP 1.1 will resolve to index.html by default, typically. Here's a protocol and its version. Notice it's got like Windows style character returns. And this is the host. This is which server you would like to retrieve data from, which is weird that it seems to be the same as this, but they're not the same things at all actually. So this socket connection here is connecting to the IP address which the DNS of sonic-pi.net resolves to, and so that'll turn into an IP address, and it'll get connected to that machine running on port 80 in the cloud somewhere. But that machine might actually be running a bunch of different web servers, all on port 80. So this is how you can actually tell it which web server on that machine to go to. So actually, we'll see in a moment. On my web server, I run a few different websites, and so by changing this second string, we should be able to actually switch between which information we get. If that works, we'll see. Yeah, and then we send the information. Oh, we totally do want to, in this case actually, totally do want to receive some data to print it out. So let's do this bit of code as well. Why is it still highlighted? How do I unhighlight things on Windows? There we are. So, what we're doing here, so it's printing out. So here we go. Now, of course, this is not going to compile right at the moment in its current form, mainly because, well, we haven't included all the headers for this. So this KN namespace it doesn't know about. It only knows about IO streams, so the standard cout stuff works. So that doesn't work. So we can do that. Well, let's try and compile it. You can actually see that it's not going to work. Yeah. Oh, actually, we've got some syntax errors first. So on line 32. Where is that error? Interesting. Syntax error, missing semicolon before. Ah, haha. So what we've got here is we have a problem. So it's there are different versions of C++, and what we've got here is that I think it's trying to compile it in an older version, and the code here is written in C++ 17. So there's some nice way in CMake to say use C++ 17. set something. Set. Here we are. Let's do this. And so we go to our CMake file, and let's go to 17. Let's see if this compiles. Yeah, loads of problems now. Great. KN : is not a class or a namespace name, which is exactly what we want to see because we haven't told it where it is. So at least that's a slightly better error. So this is good. So we move to C++ 17. And so up here we need to have our headers. We need to include the right things. So if we go to our example, we can find, here we are, look. Let's copy that across. And we also had a thread stuff. Let's copy all of this actually. We aren't using any of the chrono stuff, I don't think, in this code. So we can get rid of that. But we are using the KissNet stuff. So this is how it's defining our KN namespace. It's actually just an abbreviation for KissNet, which I assume is defined in the header HTTP file, KissNet HTTP file. But this also won't work. It's closer, but it says now, look, at least it's not going errors. It's saying can't open include file kissnet.hpp because we haven't actually got the library installed. So that's the next thing to do. So let's do that. So first of all, we need to find the library files. So hold on, I've lost the Twitch thing, so I can't see if anyone's asking any questions. Where are we? No questions. That's great. Loving it. So, but does this make any sense now? I mean, I'm doing this. Is all I've done here. All this code here. I'm not assuming you understand it at all because I don't really. I just copied it from the KissNet examples, and I just want to try and get it to work. And it's trying to pull some data from the SonicPy website using a GET request, and then all this stuff here is just printing it out to screen. Hopefully, it's not working currently because we haven't got the KissNet library locally. So we just need to go in and grab that. So. So what I need to do is I need to go to the website and download, just get the latest release, or the latest zip file, and actually, it's just from here I should be able to do that. So if I copy /man/d/downloads KissNet. Oh yeah, I've already played this before. Let's have a look at this star.zip. There we are, KissNet. Right, do we have it? Right, there we are. So let's make an external directory. We're in build. Let's get out of build. Let's make an external directory here. And let's move the KissNet. It's in build, KissNet master to external. And then go to external and unzip. Don't know unzip. Bash. That's rubbish. Actually, I can just do this. Extract all. Brilliant. And delete that. It's a nice thing about WSL Windows is you can switch between the Linux style commands and then the Windows style commands whenever you want, and also mix them together at the same time. So it's actually quite powerful to play with like this. So what I did then is I in this directory here, the external directory, I ran command.exe to switch to the Windows prompt. That I could then use the start command in Windows to then open up the Windows Explorer in the current directory, and I can use the Windows Explorer stuff there, close that, exit out of here and back into Linux. Nice. Now look at myself, look at Twitch. Baggins is saying, have you considered minting some NFTs of your music? I do not like crypto. I'm not interested in it. Right now, it feels like it's a nasty, hideous thing for the environment. It's confusing. And if people want to support the work I'm doing, they can support me on Patreon. And they can give me cash that I can actually use to spend to buy food that's real and backed by banks. And that's something I trust. And weird, I mean, I'm not totally a corporate person in the slightest, but I trust banks way more than I trust crypto. Not that I don't like maths or that kind of thing, crypto seems to be very convenient for people who want to avoid any kind of taxes or being observed or that kind of stuff. So I'm not really, it's not my thing. If you want to do NFTs, that's cool for you, but it's not for me. Right, so, and also, like, I don't really understand it. I could make a unique hash of my music, and you can buy that unique hash from me if you want, if that's meaningful to you, but just download the music and play with it. It's free. And then if you like it, support me. Okay. So, we now have, what's happened now? So what have we done? We've downloaded KissNet Master, and we've got it there, and let's have a look inside there. It's a whole ton of C++ files and CMake list test files, so that's cool. And we should be able to just use this straight away. So what we need to do is tell CMake where this is. That's the challenge. So there's an include thing for CMake. Where are we? Why is it moving this? Put this over here. I wonder if the music's going to get too loud, so let's turn the music down a bit. Okay, so let's go back to where was our CMake tutorial? That was useful. Where was it? Don't seem to have it anymore. Let's find it again. CMake. CMake. Documentation. Latest version. And tutorial. So there's a way of telling it where the headers are, and this is this target include directories. So let's copy that and bring that into our CMake list file. So we're using netcoms as our name for our project. And here we should be able to just do external / what was it, KissNet master. Is that it? That might be it. Let's go to build directory and run our CMake command. Fails. Cannot specify include directory which is not built by this project. So maybe I need to run the CMake exe file again. Errors occurred. I cannot specify include directories for target netcoms, which is not built by this project. Do I need to have change the order of these things around? Yeah, okay. So you need to specify the executable first and then the include directories. Okay. So now that's built that. So then we can then build this. Could not find. Kissnet.http. So why not? No, it's not private, though, is it? No. That was a guess. Maybe this is the wrong variable thing. Let's just check. So CMake has a bunch of variables which are useful.